My pillowcase have caught all the dreams you had last night. You're lingering everywhere in the thought of you at night. Will you be coming back and throw small pebbles at my window? I would wake up and smile instead of being trapped in limbo. I'm up for it and down for everything that you say. I cannot break loose from wanting you this bad, captivated like mad. You're a drug through my veins, like my body can take, body can take. You're so addictive, I go insane. Must have you all the time, all the time. I can't escape this rush I'm in. Did I get trapped into paradise? A breath of you triggered me, got me weak down to my knees. A mystery in your eyes that is deeper than the sea. I wonder when I got lost, walked too far in the maze of you. I'm staying here, hypnotized, I'm attached to you like glue.
Well, hello everybody. Welcome to technical session number 2. I'm emceeing, which means I get to actually invite people up here to talk. Now, we've got 4 talks. We're going to do about 20 minutes plus questions per talk. We have one remote presenter, Hassan, who's coming from Sri Lanka. So that will be interesting for our Zoom attendees as well, because it'll be fully remote. But otherwise, I am still missing one speaker, Duncan. So Duncan has turned up. Excellent. Thank you, Duncan. Okay, excellent. Thank you. So standard operating procedure, we have something to go through your slide deck with, green button, so all good. But I'll start with our first speaker from IIJ in Japan, but actually a Kiwi by birth. Oh, adopted Kiwi. Okay, so Christoph, please come up. So Christoph is going to be talking about something interesting he discovered with Apple Wi-Fi.
So, hi everyone, I'm Christoph Besser. I'm from IIJ Research Lab and up in Japan. And well, today I'm going to take you down a little bit of a rabbit hole that I went under investigating Apple's ecosystem, in particular how they do their Wi-Fi or their networking between devices and some of the issues I've encountered with that. So I forgot my accessory now, but I'm one of those strange people. I have a desktop at home that I will remote stream my games or a desktop to my phone or iPad or MacBook because it's just convenient, etc. But I started to notice that there's this strange issue that I would encounter, and hopefully we can see it when here. Yeah, here we go. So you might hear there's a bit of like a stuttering. You can kind of feel as well, and I'm just going to stop it there because it's actually really annoying even to myself. But it's this strange issue that I kept seeing occur where it's this very rhythmic type of stuttering and lagging going on. And I was trying to figure out what could cause such a thing. Now, my guess would be that I'm trying to remote stream 60, 120 FPS, 4K things. So maybe it's like my networking, there's some congestion, but this didn't make sense to me. The stuttering that was happening felt too programmatic, too precise. So maybe it's the application that I'm using, either streaming from my device or like on the device that I'm streaming to, or am I wrong? Is it actually the network and I'm just missing something and I maybe need to go back to uni and study some more, or is there something else going on? So logically, the first place to start is the application. So I use Moonlight to do my streaming. It's nice because it's free open source, and you can do low latency, 4K, 120 FPS, etc., etc. But because it is on open source and on GitHub, it means that we can try and search this problem and see if anybody else has encountered this issue. And good news, yes, other people have found this issue, describing this stuttering, micro stutter, etc. And the bad news is, there's a lot of things on the internet. Nobody's got a solution for us. And so I was kind of like stuck to like where I started. But if I look, I hope you can see this, but the application statistics here pointed out, you'd expect with the stuttering and lagging that's occurring that there would be some packet loss. But there's actually no packet loss or frames drop happening at all. But what we do see, and I hope you can see it, but the latency is quite high. It's 20 milliseconds from a Wi-Fi connection, and my IP is a meter away from me. That seems really high. And there's also the issue that there's a variance of 24 milliseconds. So again, really high for a local direct connected Wi-Fi connection. And the thing is, as soon as I swap over to a wired connection, luckily USB-C, I can do a dongle on an iPad, issue's resolved, and there's no, like, I don't see this problem anymore. But I wasn't very satisfied with the solution, and I wanted to just double check this is not the application I'm doing. So I tried to use another streaming provider. So this is Steam Link, and one of so Steam is a platform where you can buy games on PC, etc. But one of the nice things that they do as part of their streaming platform you can test your connection to the machine that you're streaming from. And they have this nice graph that they put out, and we can see this rhythmic stuttering happening, going on there. So yay, it is not just the application, but we're still stuck. Like, what is actually going on here? But this gives us an idea. Okay, now maybe is it the device or is it the network going on? So I wanted to see if this, because an iPad is very locked down, there's not a lot you can do to debug networking on it. So I tried to see if I can replicate this from my MacBook. And I ran a gping, which is a graphics ping, and you can kind of see the stuttering ping running down, and it goes down for a bit, and then it increases up again. And the big thing here is the latency goes all the way up to 90 milliseconds. Now that is really high for like a local Wi-Fi connection. And it's confusing me. I still don't understand like what could cause such a rhythmic thing. So the good news is it's not limited to my iPad, so I don't need to replace that anytime soon. Yay. The bad news is it's not limited to my iPad. So I need to figure out like what is causing this issue, because this is just running in my mind. So I'm trying to figure out what could network congestion doesn't, or like Wi-Fi congestion is normally more random. It doesn't feel so precise. So I was trying to figure out what is causing such an issue, and you don't have too many options with Wi-Fi. So logically, to try and make sure it's not congestion, I swapped over to a less congested Wi-Fi network. So I swapped over to, that went too far. Just over here, there's no other devices or anything on the network. It should be good. Nope, issue remains. I swapped over to 2.4 gigahertz. The issue remains, but now I've got a slower connection, so not ideal. So I'll be honest, I've been stuck on this part for 2 years or so, like just not making any progress. It's hard to see like what could possibly cause this. And every now and again, I do like a little Google search to try and figure out if anybody, especially with the Moonlight streaming, because it's open source, there's a few more helpful comments that come out. And because we're in the year 2024, I need to add sitereader.com to actually get anything useful out of it. And lo and behold, I found an issue on Reddit describing exactly the issue I had, this streaming stuttering on multiple applications, describing this like rhythmic stuttering thing. It's like, okay, and first of all, they're prescribing effects. Now, the first issue is that they're telling me to just swap over my Wi-Fi to channel 149. Why would, and I'm confused, why would that fix it? And the other problem is I'm in Japan. Channel 149, I can't use for my Wi-Fi devices. So I need to dig deeper and to see what is actually causing this. And there's two things that really stand out. The first is, well, this is posted on the Vision Pro. So this issue that we're seeing is happening on Apple's flagship, new devices, etc. So it's not just my old phone devices is old. And the other part is they're describing this, saying the issue is due to this AWDL, Apple Wireless Direct Link. Now, a quick question. Who here has ever heard of AWDL or Apple Wireless Direct Link before? Oh, I'm surprised there's at least one. I definitely haven't before this. I will be completely honest about that. But I'll rephrase the question. Who's here heard of AirDrop or AirPlay? A few more hands, so that's expected. Now, they're all using this AWDL. So as the name implies, Apple Wireless Direct Link, it is Apple's proprietary wireless ad hoc protocol. So it just works over normal wireless, but it allows all of the devices to talk to each other. So this allows like your AirDrop, AirPlay, you can use your iPad as a second screen, your phone as like a camera for your MacBook, et cetera, et cetera. And they kind of just like put this all under this continuity services. I'm not going to deep dive into the protocol and stuff too much. I would highly recommend, if you are interested in technical details, follow this link. These guys, I think it's our link, but it's supposed to be Open Wireless Link. So they did a reverse engineering of the whole protocol and helped fix some of the security issues and other things involved. It's actually really interesting. But now going back to the networking depth, the part that is actually interest to us. So what we're seeing is that in order for your Apple devices to talk to each other, doesn't matter where you are in the world, you're not connected to the same Wi-Fi device and etc. They have what they call like these social channels that they communicate over. So this is channels 6, 44, and 149. So that's where we get that 149 number from before. And as part of this AWDL, your devices, whenever you unlock it or you're going into your AirDrop menu, it goes and swaps over to these channels, and it starts to see, does anybody want to talk to me? Do I want to talk to anybody else? Maybe if you want to send a file, it negotiates like what Wi-Fi channels to talk over so that there's no congestion there, etc. But as I mentioned before, I like to optimize my network, and usually that is choosing the least congested Wi-Fi channels that's available. Now, the problem is that's a massive mistake, ironically enough, because what we're seeing is periodically we see hopping between the Wi-Fi channels where it would try and listen to the social channels and then go back to the normal one. Now, honestly, this is magic on the way that Apple does it, because this is completely transparent to the end user. Your connection looks stable the whole time, and as we saw before, there's not really any packet drops that's happening. They actually just delay the packets while it's listening and then swaps back to the normal one. So that's why we're seeing this delay that's popping up. Now, this felt a little bit too good to be true, so I had to test it myself and actually see, does this fix it? So I swapped over to, as prescribed, the channel 6 for 2.4 gigahertz and 44 for 5 gigahertz. And again, 149 is not available in Japan. I think it is available in New Zealand, but I'm not too sure. And it works. And I hate that this works so much. Everything about this feels wrong, but it clearly works. We see smooth, stable connection going over there, and we've gone from 50 to 105 megabits, and I'm pretty sure it can go higher. I've got Wi-Fi 6 at home, but I think the application's just limited to that. Now, to make sure this is not just on my iPad or this application that it fixes, I also did the same test on my MacBook, and I really hope you can see that, but there's a couple of spikes there, but it's very deceiving because it caps out at like 10 milliseconds compared to the 100 before. That's a massive improvement that you can feel very clearly going on there. So what is actually happening? I wasn't satisfied with just that working. So I wanted to see, is this AWDL actually the cause of what's going on? So in order to test it, I ran from my MacBook to the desktop that I was streaming. That's just connected through Ethernet to the AP. Swapped over my AP to channel 120 because I know there's nothing else on there. And I started to run a ping across. Now, the big thing is, because Apple's got like the whole control of the stack for everything, you can't see these packets on the MacBook that's actually sending it at all. It's completely hidden from you. You can do your Wireshark, your TCP dump on all of the interfaces. It's hidden from you. I believe I think it's SIP unlock. If you unlock a lot of things and go through a lot of warnings into the kernel level, like maybe you can see it there. I don't really want to do it for like my day-to-day laptop. So instead, I had a second laptop, and in the MacBooks, you can actually use it as a Wi-Fi sniffer. So I knew that 149 can't be used in Japan, so I had it sniff on channel 44. And what you see here is every time an AWDL packet is seen, regardless of what device it comes from, I've highlighted in red and overlapped with the ping RTT from the MacBook sending to my device. And you start to see a clear pattern, ignoring these for now, but here in the middle, like every time the packet comes through, we see the AWDL, we see an increase in RTT times going through in this very rhythmic, stuttery type of way that we were seeing when we were streaming before. Now, the two big red highlights here is actually when I first unlock my iPad here, and there's a lot of noise going on before it starts to stabilize a little bit. And then the second one is when I unlock my iPhone, and it lasts a little bit longer because it's 3 devices to talk to now. I didn't include it here, but before this and way after, this does stabilize when there's no communication going on between them. They go to sleep to save power or whatever. But yeah, there's a big impact when these things come through. So now that we have an idea of like what is causing this strange behavior, what are our options? What can we do? Well, the first option is don't use AWDL, which means you can't use AirPlay, AirDrop, you can't do your continuity camera, you can't use your iPad as a second screen. a lot of the reasons that you stay within the Apple ecosystem so your devices can work nicely with each other. It's the incentive, like how to keep you in that environment. But that fixes the problem for me and only for me. If I'm running a network myself, if I've got customers, etc., I can't expect them all to just turn off everything because that might be the reason that they actually bought these devices in the first place. And what about the other, last I checked, 1.5 billion iPhone users in the world. There's also other MacBook, iPads, etc. So this isn't really a solution. But I also don't know if the other option is any better. So this is what I just described before, and this is kind of the Apple way of networking. And that way would be to just use the same Wi-Fi channel as everybody else, or you suffer from this jitter. Now that makes sense in like my home environment where I've got control and there's not as many people around. But in the venue here, there's no way that we can put all of these APs on the same Wi-Fi channels. That is just going to put us back to doing normal Wi-Fi congestion. So it's a balance that you have to do there. Even in a lot of office and big build places, you just can't do that. And I'm not convinced that like a newer or faster AP is going to fix this because it can have like the fastest speed in the world. But the problem is, as the name implies, it's Apple Wireless Direct Link. The person disrupting you don't even need to be on the same Wi-Fi connection as you. They can just walk past, unlock their phone, maybe open up AirDrop, and this communication will start to happen. And I haven't had a chance to test on if there is social channels on 6 gigahertz. I did see that the conference venue has got 6 gigahertz Wi-Fi, so I might do some digging on that in the next couple of days. But at the same time, if it's going to do the same thing, we're stuck about where we are. And ironically enough, Apple's been really pushing this RFC 9330 L4S, which is mainly just to reduce network delays between your application and the end users. But this is on a protocol level. The issue that we're having here with the Wi-Fi is it's swapping like the Wi-Fi channels over. So this protocol is not going to fix that issue at all. And the thing is then, if you really want to avoid this issue, like, should Apple really decide how we do our networking? Again, it makes sense for my at-home. I can, where I have access to it, but a lot of apartments don't have access to that. My hotel, I can't change the channel that I'm using. So if I'm lucky and it's on 44, I don't have any issues. If I'm not, well, no more games for me. And the thing is, I'm kind of talking about things, but like, it's a double-edged sword. I have no intention on moving away from Apple anymore at the moment. Especially for traveling, I use my iPad as a second screen, and it's really convenient. But I have to realize that it comes at a cost, and issues like these can be really hard to debug. So I'm just talking about my personal experience of going through it, but maybe you as operator or provider, maybe you have some tickets of people complaining of an issue similar to this, and maybe this can go and help them out. And if you've encountered this in the wild or in a ticket somewhere, just remember, just try Wi-Fi channel 644 and 149. And the problem is there's not a proper solution. At the end of the day, the only people that can fix this is Apple, updating the devices. They've had this protocol around for over 10 years now. And the best I can do, put in a bug report and waiting to someday maybe hear back from it. And then the other thing is, I don't know, maybe I'm making just a mountain of a molehill. As I said, there's actually no packet loss. It's just an increased latency during this time. And eventually the connection will stabilize until another Apple device shows up. But on the other hand, cloud gaming is growing. Like, I've just showed a best scenario, like I'm in a local connection having this here. The likes of the most popular ones that I could find numbers is GeForce Now. A year or two ago, they had like 20 million subscribers. Xbox Cloud Gaming's got 34 million. And they will have, like, you can have 100 gig connection, like fiber to the house, etc. But if it's the Wi-Fi and the last mile that, like, in that last bit that's destroying it, like, you're going to have issues. And the thing is, the people they will blame is either going to be the cloud streaming provider or the ISP, so the people probably sitting here, and you're going to have tickets of people with these issues. So that is the end of it. I will try and take questions as best as I can, but I wanted you all to just suffer a little bit with me with this issue and maybe come up with some solutions for any potential tickets or issues you guys have.
Awesome. A couple of questions will be great. Yes. Step up to the microphone. Remember your name and your affiliation, please.
Hi, I'm Mark Foster. I'm here for the New Zealand Ministry of Health, but I'm speaking personally in this case.
Okay.
What you described sounded an awful lot like the interleaving discussions we used to have on DSL lines for residential customers. So you'd have interleaving, which introduced artificial jitter and latency as an error correction method. And friends who worked at ISPs might quietly turn off interleaving to lower people's latency for gaming purposes.
Yeah.
That's what it reminded me of. It occurs to me that the fix needs to be some sort of ability to turn it on and off dynamically. So if you know you're doing something which is jitter sensitive or latency sensitive, then you can turn off that feature set for the duration of your streaming session or your gaming session, and then it comes back on again when you're not doing those things. Is feedback, and I'm not an Apple ecosystem user, but is feedback being given to them and stop breaking by networking? You know?
So that is potentially an option to do. And the thing is, to an extent, they have this capability they've released in the last iOS version, I think, where they've got this now quote unquote game mode they've introduced. And I think it's only with the next upcoming one, they're doing it for iPads and iOS. So theoretically, if it's on the game mode, they can make sure, hey, let's reduce the other one. The other option is to do, and I think this is the way that the likes of your Android and other devices doing, like the Wi-Fi Alliance way of maybe doing like a Bluetooth Low Energy to do the social channels instead of doing it over your normal Wi-Fi, so to avoid that swapping over. But that's something I still need to investigate a little bit further and to see how exactly everybody else is doing it.
Awesome. Thanks, Christoph. A round of applause, please, for Christoph. Next up, we have Duncan. Duncan, did you want a mic up or do you want to grab a portable mic on the way through? Okay. Christoph's actually wearing it. Are you giving away chocolate too, are you? Oh, dear me. So Duncan's talk is going to be very interesting because it comes at a crossroads of the technical and business. He's going to be talking about quality of experience, which is something that, if you're in marketing or you're in another salesy type position in your ISP, getting something other than, we're really fast internet is an interesting business proposition. But I'll let Duncan take you through this. But it's a very interesting concept.
Hey everyone, just checking that's working. Seems to be okay. Hey, so I'm Duncan Cameron. I'm actually a PhD candidate in my final year at Victoria University of Wellington. I'm here today on behalf of LibraryQS, which is probably my favorite open source software project. And before we get into it and what all this is about, I just want to ask the room, does anyone know what buffer bloat is? Got a few hands. Does anyone want to exchange a definition of buffer bloat for a selection of fine New Zealand chocolates? We have an almond gold, a cream milk, and a peanut slab. 5 o'clock, I'm sure someone might be needing it. Or I'll just hand them out. That's also okay. Any takers? Ulrich, is that your hand? Oh, yeah, go on.
Other devices that need to send and use because
Perfect. Do you have a preference? Cool. Shall do.
Should I note that's your supervisor? Oh, no, actually, no, he's a VUT. Oh, okay, so there's no supervisor intervention here. Good.
No, they are hiding here in the audience somewhere. There you go. Thank you very much. Cool. So let's go next. So just a bit about buffer bloat. So buffer bloat is an unwanted queuing delay. So it's very common in first out queues. So if we have to take a look at these measurements, which are taken from a wireless internet service provider, who should be involved with running, we can sort of see the times of the day that they become a problem. And of course, these coincide when the network is under the most utilization. So you can sort of see here around when people start to come home from work, packet backlogs to go up. And in practice, the distribution of latency measurements, which are a lot higher with these TCP and SYNAC times and the DNS request response times, which seems to have been cut out the bottom there. It's oh no, sorry there. Yeah, much higher. So around sort of 4 p.m. through to midnight, the distribution is much worse, and we start to see observable buffer bloat. So this is a problem for service providers that are sort of constrained by whatever equipment that they've got running in their networks. So if your equipment is just using first in, first out queuing, you're probably going to be in for a bad time if you actually are hitting anywhere near sort of that capacity of those links. So in the case of the network here, it's a clear indicator that this link is actually in need of dire replacement. It's at capacity during peak hour, and either we need to do some sort of active queue management or we need to replace it with an even faster link. But of course, with capacity constrained networks, such as those using sort of fixed wireless, unlicensed fixed wireless especially, this isn't always an option for many, many reasons. Power consumption of the radios often being one of them, especially when the sort of sites these are installed at are powered by solar power. So we needed a sort of drop-in replacement without disrupting too much to the network, without costing network operators too much to go in and rip out equipment, replace it, just for the sake of better latency under load. And that's where LibreQS comes in. So LibreQS is an open source quality of experience enhancement platform, and it operates as a middle box shaper. So actually deploying LibreQS is pretty much as simple as dropping in what's an Ubuntu server. So it might just be something sort of 1U into your rack, and then it just acts as a transparent bridge between your distribution router and whatever core router or switch that you're running at your head end. So really, really simple. Actually getting it installed sort of only takes, 5 minutes if you've already got the hardware there ready to go. Couldn't really be any easier. So at the heart of LibreQS is FQ and AQM, so flow queuing and active queue management. So effectively what these two schemes are doing is just when we are nearing the utilization of the links, they are just applying better sort of pacing to the packets which are coming through. So real-time voice and video is going to be prioritized over bulk and sort of best effort flows, of course. So from memory, LibreQS actually sort of came about during or slightly after the pandemic. So suddenly everyone had to work from home. And historically, buffer bloat, it's been an issue for many, many years, especially as buffers have sort of grown, but the mitigations to this problem haven't really been sorted. And with people suddenly having to do video conferencing and whatnot, it became more than just gamers complaining about why am I, during peak times, is my performance, my ping so bad? So suddenly there was a real incentive to actually come in and fix this, which is what the LibreQS authors, a fellow named Mr. Chacon, so he runs a WISP wireless internet service provider in Texas, Robert, and he pretty much put together a bunch of Python scripts, and these controlled so CAKE, Common Applications Kept Enhanced, which is an approach to FQ and AQM to subscribers, and using that is able to sort of improve the performance under really heavy network utilization. And then as he sort of posted this publicly, he got more and more interest from the wider networking community. An author of some Rust courses, Herbert Wilson, came in and actually rewrote a lot of LibreQS's original Python implementation in Rust. And it's sort of just grown from there. There's a few people involved in the project, and it continues to grow to this day. So primary capabilities of it. So we're kind of doing two things with LibreQS. One of them is, of course, the FQ and AQM to subscribers. But due to the way it's architectured, we're able to also do really, really scalable latency monitoring as well. So that's a key point that we'll get into shortly. Because it is a middle box shaper, of course, we can also sort of enforce whatever plans we're provisioning to subscribers. Then mitigate congestion on backhauls and any other potentially congested points within the network. And LibreQS currently sort of split into two things. So there's a fully open source product, LibreQS itself, and then there's the long-term stats version, which is available for quite a reasonable small fee. And that's just to help the developers eat dinner every night. So at the heart of how all this works is XDP, or the Express Data Path. So there's some limitations with just the sort of default Linux bridging. It's a little bit slow. It's getting faster year by year, but XDP bypasses not absolutely everything, but a great deal of sort of traditional internal networking, and you're able to build some really, really high performance solutions with it. LibreQS being one example. Kernel bypass networking in general is becoming more popular sort of across the board. XDP is sort of this nice Goldilocks area, but there's also things like Cisco's VPP, the vector packet processor, which I believe is actually at the heart of some of their routers, sort of just in the background there, and that's able to scale up to several hundred gigabits a second, sort of within modern x86 hardware, which is really quite remarkable. And with this, we're just leveraging XDP, but for purpose, it scales very well, and we'll also get into that shortly. So at the heart of LibreQS is Cake, or Common Applications Kept Enhanced. So it's the successor to FQCodel, which some of you may be familiar with. So FQCodel is flow queue control delay. This has become quite popular worldwide. It's now actually the default scheduler within Ubuntu, and I believe possibly Mac OS as well, but maybe don't quote me on that just in case. So effectively, yeah, we sort of see the result of a test with FQCodel running on waveform speed test here. So we don't have any increase in latency under load. If you were to run this with just traditional first in, first out queuing, you'd expect that, you know, behind a home Wi-Fi connection, this would actually probably be quite bad. And you can easily test that, and I'd be interested if anyone feels like actually doing a test in the audience. If you go to waveform.com, you can run that test and you'll see if there is any significant increased latency under load. And it's probably worth considering that, you know, for day-to-day browsing, this may not always be an issue, but if you're doing things like real-time voice and video, Zoom calls, someone in your house starts downloading BitTorrent traffic, and someone else is trying to, you know, join a Teams meeting, you're going to run into problems, and this solves that. Yeah, so modern LibreQS is fully written in Rust with some Python extensions for the CRM integrations, just for sort of keeping ease of maintainability, and you know, it makes it more approachable for people that might not be familiar with the systems languages such as Rust actually get involved with the project. But it's been very, very stable. I mean, Rust is a memory-safe language, and we haven't had any reported crashes of this within production since version 1.4, which is quite remarkable, really, given it's now actually been deployed all across the world. So as well as the actual subscriber connection enhancement, so there's also eBPF accelerated latency monitoring. So because we're running this transparent bridge and all of our subscriber traffic is passing through it, we also have really great visibility into the latency of all of these connections that are passing through it. So within the LibreQS platform, we can provide a really, really good overview of sort of the average TCP round trip times and this histogram here, as well as just, you know, things you might expect, such as the packets per second you're processing, the top downloaders, but then delve even deeper into that by looking at sort of a map of where all the flows are going, you know, what geographic endpoints are these flows being terminated at, and even deeper into protocols, ETH types, et cetera, as well as a quick little overview there of who has the worst performing connections, which is really beneficial for figuring out when stuff's going wrong. Oops. Cool. So in actually configuring LibreQS, it's very flexible with how you can use it. So you can input a hierarchical network topology, and the benefit of this is basically you can be quite flexible with how you configure it. So sort of competing schedulers quite often let you just define like access point capacity and sort of your plan capacity for subscribers. But with LibreQS, you can actually define this all the way through the network's hierarchy. So you might have a site, that site might have some micropops hanging off of it, as well as other backhaul links between sites, and you're able to clearly define how much capacity every single link within the network has. And the reason this is so helpful, so with LibreQS's hierarchical token bucket sort of approach to processing these packets that are running through it, you're actually able to never overutilize a single link. So if you come near the utilization of it, the FQ and AQM will really, really take effect, and you're not going to sort of be self-defeating in that you know, you've only configured the the maximum capacity of an AP and however much bandwidth you want subscribers to have. So yeah, it ensures that the FQ and AQM works all the time, is the gist of that. And with the XDP, we're actually currently able to scale up to sort of 50 to 100 gigabits per second on quite affordable commodity hardware. So the biggest cost of these LibreQS boxes currently is actually the network cards. But I mean, TradeMe, the local New Zealand equivalent of eBay, you're actually able to get sort of off-leaf hardware from there very, very cheaply. And some of these things, which are sort of the sub 1,000 New Zealand dollars or approximately $600 to $700 US, will actually get you scaled up to already around 10 gigabits a second of shaping capacity with quite minimal CPU overhead. So it's really incredible what you're able to achieve these days with just commodity hardware. And that's probably only going to get better, especially as x86 processors improve year on year. AMD's been doing really well with some of the new stuff they have, and it's probably only going to get cheaper. So LibreQS LTS. This is the future version of it, the enhanced version. Oops. So basically, we've taken everything that normal LibreQS has and sort of made it nicer for service providers to actually come in and utilize. So any Star Trek fans might recognize the Klingon. Just to avoid accidentally leaking any subscriber information, everything in here has been anonymized. Yeah, basically it just has an improved user interface. You can view all of your LibreQS boxes in one place. It's commonplace to have probably one set up in the head end of your network, but there's nothing stopping you actually deploying more, sort of at sites or at a fiber point of presence and so on. Yeah, monitor it all in one area. And we have a nice heat map to give you a good overview of sort of where problems are going wrong without having to, go searching through logs of subscriber latency and whatnot. So you're able to log in just at a glance. Maybe every morning you might go and check, is anyone having an especially bad connection day today? And if they are, then gives you better sort of time to resolution than what it does waiting for them to call up and complain, which is the real key of it. And as we know, especially within capacity-constrained networks such as this, there often is a lot of oversubscription. So with FQ and AQM, the more you can utilize your links oversell them without actually impairing subscriber performance, the better, because as we know from sort of like Ulrich's talk about Starlink and that, there is a lot of competition coming to the market. We have Amazon entering this market soon. So really anything you can do to give these providers the edge is worth doing. And this is just one such example. So if you can sort of utilize 90% of any backhaul link in your network or access point without people sort of realizing you're actually, utilizing it to that degree, then great. So this case, this particular link has been oversubscribed by 3,500%, which is a lot, probably more than it should be, but just sort of goes to show what you can do with it. And yeah, just much the time, sort of touched on that, but no matter how many LibreQS boxes, chuck them all in one place. So this is a cloud-hosted solution, which is a little bit different to the traditional LibreQS, which is hosted on premise. But if it's a benefit to anyone, it is now available. And so how do we actually integrate this into the network? So we sort of touched on it, but it's really easy to create a test bed, and it's literally as simple as this. So you can do this at home if you don't mind having a server running with Ubuntu on it. Basically, internet connection, you have a LibreQS mailbox between that and your distribution switch. So it runs as a transparent bridge. It doesn't have addresses. There'd be a separate management interface there. And then you can load up whatever test devices or clients you want south of that distribution switch and actually see it in practice. Thoroughly recommend anyone that's interested in it to actually go out and do it. It's very, very easy to set up. The installation script is provided, and you only have to sort of input a few little things, and then you're installed. And LibreQS team is willing, just because of sort of where the project's at the moment, to actually work with people that are interested in integrating their CRM platforms or anything else to actually function alongside LibreQS. So there's some already. So for like UISP by Ubiquiti, Sonar, PowerCode, and Splinx. But yeah, they're happy to work if you've got some specific use case. actually go about trying to integrate it as well. And an actual deployment, it's really not any harder than just creating that test bed to get it up and running. And the real benefit of this is you're dropping in a middle box rather than actually going and ripping out subscriber equipment to improve the subscriber's quality of experience. So pretty much it's just a case of what we showed before. In a service provider situation, you have some expectations about it being perhaps higher availability. So you usually run OSPF for something between these two routers, and LibreQS route is the low cost one with a high cost backup in case that fails. And you simply then go and define your network hierarchy and then start shaping subscribers. And LibreQS community worldwide is growing. So currently we're in over 46 countries, 24 US states. Southeast Asia is certainly one of the biggest growing markets, but there's a slow uptake in Africa, arguably where some of the developing world benefits most from this. So one of the others, Frank from the project, actually had a talk in Malawi recently, and compared to even New Zealand, the challenges they have with the cost of bandwidth are absolutely massive, and it is where really utilizing your links as much as you can without having to purchase more capacity from an upstream. It's a real benefit. And it's probably going to be like that for a little while. And thank you all for listening. That's I talk on LibreQS. Does anyone have any questions?
Cool. Yeah. Thank you very much for that chat. Oh, you're giving away more chocolate? Excellent.
For this side?
We do have a little bit of extra time because we may be missing a speaker. So if there are any questions, please approach the mic. Your name and your affiliation, please.
Duncan.
Hey, John.
It's Jonathan Brewer. Hi there. As you know, many WISPs use backhaul links that can vary in capacity depending upon the weather. This is a feature, not a bug. But
Yes.
when you are trying to do hierarchical queuing and you're expecting a pathway to be 500 megabits per second and instead it's 350, what do you do and how fast can you adapt to that?
Yeah, so this is an area which does remain a little bit of a challenge to this day, unfortunately. It is an area of active development. In my own experience deploying LibreQS and my former WISP network, I was quite pessimistic with the backhaul capacities because of this reason, at the expense of slightly more bandwidth for end users. But currently, I may be wrong here, and I'd probably check with the guys, but I think it probably is a little bit of a hole that still needs some work. But certainly you can reload the LibreQS configuration without inducing any packet loss. So you could change the capacity of any of the links within the hierarchy dynamically. But I believe there's no automated way to do that as of now. But it's certainly something of great interest for the future. And I think AL work.
If I just quickly comment on this. So the discussion that I've just witnessed is one that I've actually seen in various sort of expressions before, and it's what's going on between communications engineers who are coming from the bottom of the protocol stack, and who, when you talk about the term packet loss, think about terms such as signal to noise ratio, bit errors, symbol errors, and this sort of stuff. And that tends to clash with people who, like you guys have developed LibreQS, who are coming from the networking end, for whom packet loss is associated with congestion and with buffer drops. And the buffer drops happen simply because the buffers overflow. And the general problem behind this is that people then think, oh, I've lost packets here because my buffer ran out of capacity. So let's go and add more buffer capacity. So we're not losing those packets. And they're overlooking that packet loss is actually an integral part of the regulating function of TCP and other protocols that are trying to fill a pipe and will continue trying to do so until they start losing packets, which is an indication for them that they've reached the capacity of the pipe. And those are two completely different packet loss mechanisms. and they really don't have all that much to do with each other. So LibreQuas is trying to solve a different problem.
Yeah, it would be fair to say that, I think.
Yeah.
So I know with Cake and FQ Codel, like, so just on that, like, I think there's a fairly long history of like deficit round robin sort of approach to signaling upper layer protocols that actually we're reaching capacity or at capacity. That might sort of help. But no, I do agree that it probably does come back to there's often maybe not a lot of communication between people working at like the lower level comm stuff and then, upper layer networking. And I think more cooperation there would probably help everyone in the long run. And you certainly see a bit of that chatter on the, I know like the Starlink mailing list, I think you're quite active in, and certainly the Bloat one as well, and some of the others. But yeah, certainly the more collaboration between industries, the better for solving this for everyone in the long run.
There's a real risk of people talking past each other.
Yeah,
Because they're coming
totally.
from different training backgrounds and different things. But it's important that when you look at a problem that involves packet loss, that you diagnose where that packet loss is actually coming from and what's causing it, as opposed to simply assuming that it's necessarily coming from the domain that you're most familiar with. So this is where John really has a point. If it's weather related, there's very little that LibreQuas can actually do about it. It can't make the rain fade go away.
Yeah, that's yeah, unlicensed links especially are going to remain a challenge for many, many years for many people, I'm sure.
Hi, I'm Jonathan. I'm from Chorus New Zealand, which is a local fibre company. Local fibre networks tend to be very consistent capacity, and the packet loss comes from unexpected demand, which hasn't been catered for. Is there any value you see in local fibre companies implementing a LibreQuas box to improve service to customers?
Oh, I'm actually very glad you asked, because we have seen some deployments that I know of, maybe not in New Zealand for fiber optics, but certainly in the States and that, where there's sort of multi-dwelling units, people have found, I guess also just because of overselling links, that there definitely is value in it. I think given the very healthy state of fiber in New Zealand, probably not so much right now, but certainly if we do start oversubscribing links in the future, potentially, or definitely potentially.
Chorus is regulated and has maximum utilisation levels imposed by the Commerce Commission, and I assume other fibre companies have the same issues. So do you actually see that being a problem in the future?
I mean, if things stay the way they are in New Zealand, hopefully not. I mean, it's a good world where we don't have to worry about this. I think while we have world-class infrastructure, maybe we won't need them within the fibre networks here, but certainly, as more ad hoc ones start to get built around the place, in the MDUs and other developments which might not be built by Chorus, I think there will absolutely be value in them. But while we're keeping them regulated, keeping the maximum utilization of this GPON equipment below quite a threshold, then probably not so much. But I mean, I may not have the same opinion as some of the others on this either. Be interested to have a wider discussion about it.
Cool. Bias, last question, and then we'll move to the next speaker.
Hi, so yeah, I'm Toby from the University of Auckland. You mentioned that it was written in Rust.
Yes.
Do you see that as perhaps a potential issue to more widespread adoption, given that particularly in Linux, even down to the kernel level, there are people actively discouraging Rust over C?
Oh, I mean, at this point, I don't think it's discouraging for anyone for the uptake of it, just because most of the end users hopefully won't have to be worrying about the underlying implementation. For future development of it, I mean, at least definitely while Herbert, the Rust book author, is on, well, sorry, not the Rust book author, but he's an author in many Rust books, is still involved with the project. I don't think it will be an issue. I have seen some of the sort of political issues around Rust and the contentious use of it flare up, but I think for now it shouldn't be an issue. I mean, hard to say what the future holds, of course, but yeah, it's got very good backing of the people currently working on the Rust part of it. They're very, very experienced systems programmers, so
Thank you.
that's a valid point to ask, of course.
Well, thank you very much for your presentation. A round of applause, everyone.
Thank you all.
Our next speaker is from Japan, Miho, and she's addressing an interesting issue to manage internet resource allocations in businesses. So it's a solution that's come out of the company she works for, Docomo. So thank you very much, Miho. And you're fine to use the lectern? All good? Yeah, thank you.
Yes, okay, so hello everyone. My name is Miho Moriyama, and I am here to make a presentation on behalf of NTT Communications. And I'm very nervous because this is my first time to make a presentation in such a big conference. So I'm happy if you listen to my presentation and watch me warmly. So let's begin. And so today I'd like to share with you the importance of the importance of centralized management of network resources in business. So before I begin my presentation, let me first briefly introduce myself and my company. So I belong to NTT Communications, a telecommunications company that offers a wide range of ICT services, including network, cloud, data center, application, security, and AI, utilizing its high-quality infrastructure and technologies. So this is quite sudden, but do you know what these numbers in the bottom are? So the answer is the number of systems, the number of IPv4 addresses, and also domains that my company maintains. So our company maintains so many network resources in order to provide stable services. If you can, please keep this information in mind as you listen to my presentation. So I also want to add my information. I belong to the Information Security Department to manage our AS numbers, IP addresses, and domains. Today, I'd like to share with you how we manage these assets. So maybe this is very simple, but I hope it will help you gain good insight into your own company, group, or organization by going back to the basics. So this is today's agenda for my presentation. The keyword is centralized management. And how do we manage and how do we get there? I hope you will find today's presentation interesting. So now I would like everyone to think about a situation of having, a large company having about 10,000 employees using the company's network resources, such as IP addresses and domains. And which are the company's own assets and are all managed separately? What do you think would happen in such a situation? So I want to suppose
I think we might be having some problems with comms. Yeah.
Okay, thank you. Okay. So suppose a security incident occurs in this situation. As you can imagine, if the different network resources are managed in different ways, it will take a great deal of time to respond to the incident. This is because the information is not organized. And the scary situation I just mentioned was actually experienced by our company. An attacker attacked our internal systems and successfully implemented an internal intrusion. This was a major enough incident to warrant a press release in 2020. In order to minimize the damage when a security incident does occur, we set up Communic. As you may have already noticed, Communic is coined from the company's name and the Network Information Center's acronym, NIC. And so the hierarchical image is shown on the right side of the slide. And Communic has three major roles. The first is the formulation of management policies and operational guidelines, along with their internal dissemination. So we strive to ensure that everyone can use network resources in the healthy manner under the same rules. And the second is responsible as a contact point for external organizations such as APNIC and JPNIC, and also as well as our internal users. And the last is the centralized management and updating of the usage status and user information for each owned resource. So as I mentioned at the beginning, centralized management is today's keyword. So I would like to go into detail in this talk. So next, I would like to explain how we created a centralized management system. So we divided the process into three major phases. The first was to create a box to store information on network resources. And we developed this so-called platform. And the second phase was to collect information to put in the box we had created. And the last phase was to utilize the information. So let's look at each of these in detail. We have devised a mechanism for centralized management and of network resources shown in the diagram here. So as you can see in the middle, we developed a system for centralized management and put all the information in it. We also made it possible for users and Communic to exchange the information through this system. And as I mentioned earlier, my company used to manage network resources on a user-by-user basis. Therefore, we decided to have a hearing for every single piece of information about all of them. And this information includes which organization manages them and when they have been managed, and so on. As I said at the beginning, our company is a big company and have a different many systems. So these hearings required steady effort over a period of time and were hard work. However, these hearings were really important as basic information. The information actually available at a hearing is managed on the platform mentioned earlier as shown here. So please note that this is actually what we use. So it is written in Japanese and also masked. As an example, this is a management list of global IP addresses used within our company. So basic information such as address range, the number of addresses, and contact information can be seen at a glance. And also, it is not just basic information. We also wanted to collect such additional information as who is, do the domains support DNSSEC or not, and so on. We set up a server to collect these additional information and put all of it into the network resource management system. So this is also a real image of the additional information in the network resource management system. So as you can see, there are DNS information and information of certification, and also like SPF, DKIM, and DMARC records. So the information gathering of the previous phase does not end once the information is registered in the network resource management system. It is quite important to keep the information fresh. For this reason, we are working with our internal human resource system to avoid having any resources being without specific managers. When the human resource system detects that a person listed in the administrator column of the network resource management system, it automatically notifies the person in charge of that resource and instructs them to update the information. There are also measures we are taking in cooperation with other departments and also other teams to check the information we have gathered for security perspective. So one of these measures is to prevent the misuse of domains by drop catchers. While it is a legitimate domain cycle for an expired domain to be reused by another users, the domains with strings such as NTD in their name can be abused as fraudulent sites. In order to reduce such risks, we have decided to retain even domains that are no longer in use for a long period of time, and in cooperation with other departments, a separate infrastructure has been established to monitor access to this expired domain to check for residual links. And I want to show one more example of the security measures. We also use the attack surface management tools to check how our network resources are evaluated by other third parties. So this is the last slide. I want to conclude this presentation. We have established an organization called Commonic to centrally manage the company's network resources after a single security incident. It is very important for a large company to centrally manage information on network resources. In addition to the purpose of launch of Commonic, which is the background for the launch of Commonic, a visualization of our assets is our first step for implementing various security measures. So as was mentioned in the previous example, such as a visualization is used for attack surface management. And in the near future, we would like to make effective use of this information we have gathered. And one example is we want to work to increase our internal RPKI and DNSSEC compliance rate to 100%. So our activity is taking shape, but I think we are halfway there in terms of keeping the company's network resources secure. So I'd like to continue to exchange information at meetings like this and give back our company as we carry out Commonic's activities. Yes, so thank you for your kind attention.
Well, Miho, congratulations on your first conference presentation. Very, very well done. Do we have any questions? Please approach the mic, name and affiliation, if so. Well, I'd say another round of applause for all our speakers. Thank you very much today. We were expecting a fourth speaker online. Unfortunately, technical difficulties have meant that they've not been able to join the Zoom from Sri Lanka. So that means we have an extra 24 minutes up our sleeves, and we'll be finishing now on this session. So apologies if you had plans to stay here for a little longer, but unfortunately, sometimes the internet doesn't work.
Yeah, you can talk to me, boy, and you can move it up close, but that's as far as it goes. I'm not your baby, I might be up for a dance, I might be holding your hand, but that's all I can stand. You're not gonna get what you came here.